Hi all, so this is Balakrishnan. I am here for presenting my digital assignment for CyberSecurity course. So let's start. So today what we are going to talk about is MAC and HMAC, Message Authentication Code. So what it is all about, see, let us build the intuition step by step. Let us not worry, let's go start from a very simple concept and then build it and say how it handles the entire scenario and how it's not tamperable. Let's start it. So there are three people in this scenario, okay. One is the hacker, another is A, another is B, okay. So A is sending some message to B, okay, fine. So where does it come from? Okay, okay, so these are three people. Just pause a moment and go here, okay. Just read what is MAC, Message Authentication Code, okay. So what is meant by authentication? First of all, understand that. Okay, there is a difference between authentication and authorization. Authorization is setting up the levels and setting up like profile. Okay, like for an example, in VTop or in some application, if I log in, it's something different. Student profile opens and student level permissions are given. And if a dean logs in, it is the dean level permissions which are being assigned to him. So, what is meant by authentication means authentication is it you? Okay, is it me? That is authentication means. Okay, so when B is receiving a message, right? It can be sent by A, it can be sent by hacker, it can be sent by someone, right? See, someone can interpret that it is I am A and send a message to B, right? So this is the problem. Okay, so there is no surety that it is mine. It is sent by me. Okay, like we need some sign or something kind of that way. In real life, if there is an application or if there is like a form or a checklist in which the people sign and then we will send it to them so that it is being authorized that it is sent by me. Okay, it is being authenticated that it is sent by me. Okay, so that is missing over the internet, right? So in order to handle it, we have this MAC. Okay, so what it does? Okay, see, basically A has a secret key K and then B has the same secret key K. Okay, so the message plus this MAC, okay, is being attached together and then sent. Okay, so by this MAC, user B, right, can easily identify that whether is it from A or not. Okay, because the secret key is only known to A and B. Okay, so let us see. Okay, see what happens is that there is some message. Okay, there is some message. Okay, A, B, C, some message is that. Okay, we will be finding the MAC. MAC is nothing but MAC is a function. Just assume it as a function, okay, in which the message is given as a parameter as well as the secret key. Okay, these two things are given as a parameter to this function. Okay, function, and then it returns a value. That is the HMAC value. That is being appended, okay, with the message and then sent to the sender. Okay, so this is how it works. Okay, so now you may ask me, okay, so what, like how does it verify? Let's first see how does it verify and then let's see what are the ways a hacker can tamper it. Okay, so how it is being sent. So I told these are the things which A need to do, right? So we saw how generation happens. Okay, generation happens by A. Okay, it does it, it appends it and it sends. Okay, so now let us see how the verification happens. Verification happens. Okay, and that happens at the B's end, right? Because it is the receiver of the message, right? So now let's see how does it happen. Okay, so in the verification, right, like we can see it. See. Basically, that is B, right? Okay, fine. So it receives what it receives. It receives message plus MAC. Okay, message plus a MAC value. So what it will do means it will take this message part alone, which is both are appended, right? So it will just slice this off, take it, and then it has its own secret key, right? It will keep it and then put it as a function for the MAC function. Okay. It gives it as an input parameter to the MAC function. Okay, so for this function it will input it and then it would input it and then so basically it would input it and then you will get a MAC value, right? You will get a MAC value. Okay, cool. So it will input it and it will get it as a MAC value, and then so this MAC value will be compared with this MAC value. Okay, it will just compare if the calculated MAC value, if the condition is if the calculated MAC value is equal to the received MAC value, then it is true. It is a correct message. It is being sent by A only, and it is not being intercepted, or nothing has happened to the message, right? Else, if it is not equal, right, then it is not. Okay, then it is not being sent by A, or it is being tampered, okay, by someone else. So by this way we came to conclusion, right? We have this mechanism to generate and to verify. Okay, fine. So now what happens? Okay, so after verification, so let us see how it can be tampered. Okay, we now saw both the things, right? Generation and then verification is now done. Okay, now let's see two cases in which the hacker can tamper it. Still he can tamper it, right? See, let's say case 1. Okay, case 1, what happens is that let's say he is tampering a message. Okay, so let's assume the message as cyber. Okay, cyber is the message, and then the MAC value is like KLM123. Okay, let's assume. Okay, this is just, everything is not the real values. It is just an assumption. Just to explain you the concept, just understand this. Okay, so this is the message. This is the MAC value, and both the things are appended together. Okay, fine. So when both the things are appended together, we will keep it. Okay, fine. So now the hacker can tamper this message. Make it as like what? Like what to say? ML. Okay, MLDL. Okay, he can make it as MLDL. Okay, instead of this cyber. Okay, he can make this thing, and then what happens? Let us see. Okay, so he has tampered the message. Hacker has tampered the message. Okay, so now this thing, the whole part will now go to B. And what we will do? We will take this MLDL and then put a secret key, and then give it as an input to the MAC function, and then it will get a MAC value. Okay, that would be QRT341, something else. Okay, I'm not sure. Okay, this is something else, but I am sure that these two things, right? These two things will never match. Okay, it's mainly because the message has been tampered, right? The message has been tampered. The secret key is same. Okay, if it was cyber and then the secret key K, then the MAC value would have been KLM123. Okay, now it is not cyber, right? So if it is MLDL and then the K value, okay, the same secret key value, okay, given to the MAC function, it will never match. So that is the thing. So we have identified it, right? Cool. So one of the case to tamper has been tackled. So it has been tackled. Okay, cool. So what is the second case? Let's see second case. Okay, case 2. Okay, case 2 is what if he can tamper the MAC itself. Okay, let's say again message is cyber. This is the message, and then K is what? K is the secret key, which is let's say again KLM123. Okay, if say he is tampering this key itself, then also it is of no use, right? See, KLM is there. Instead of KLM, if he is going to make it as QLM123, okay, then what happens is that instead of this, if hacker is going to do this, okay, and then give it also, what happens is that for this message, right, message is not tampered. So cyber, okay, comma K, when it is being inputted to the MAC function, it returns a MAC value. Okay, it returns a MAC value. That would be KLM123. Okay, it will never match to QLM123. So again, we have identified it. Cool. So now, you may ask me one more case. Okay, one more case. Okay. So in both the cases, we have seen that it is untamperable. So this technique is working. So now you may ask me case 3. Okay, case 3. You may ask me if the message is cyber and the key, the MAC value is KLM123. So now, what if the hacker comes in and then make it as MLDL and then find the MAC value for this and then append the new MAC value, okay, new MAC value. If he appends the new MAC value and then if he sends it to B, okay, and then if he sends it to B, right, to B, okay, so now B cannot identify it, right? You may ask me that. No, that is where the secret key helps us, okay. The secret key is known only to A and only to B, okay. It is not known to hacker. It is not at all known to hacker. So secret key is K is not available with hacker, okay. So that is the biggest plus point to us, okay, because of which hacker cannot hack it. Okay, what happens is he cannot find the MAC value, okay. He will find his own some MAC value putting his own secret key, okay, K dash maybe, okay, that would be the secret key with him. He doesn't have K at all. That is the biggest point that you have to note, okay. So because of which, whatever MAC value he is finding, right, so MAC of message, okay, message, comma K dash is never equal to MAC of message, comma K, okay, when K dash is not equal to K, okay, when K dash is not equal to K, the MAC of message, comma K dash and MAC of message, comma K will never be equal. So that is again the biggest point which is holding this particular technique, okay. So now let us see, okay. So now we have seen how MAC actually safeguards the authentication process, okay. Now next we will be moving towards HMAC. So just keep on watching. So yeah, so let us now continue, okay, on HMAC. So what is HMAC? So HMAC is hash based MAC, okay. So it is as similar as MAC, okay. Whatever MAC does, MAC was a function, right? So HMAC is also a function, okay. HMAC is also a function in which you will input message and then the key, secret key, okay. By inputting both of these, you will be returned with a HMAC value, a fixed length value because it is using hashing, and then that would be appended with the message, and then this whole is sent to the person B, okay, cool. So this is how it happens, okay, the exact same thing like how we used it in the MAC, the same way HMAC also functions, but it is a hash based MAC, okay. So yeah, we all know about hashing, right? Like there is like SHA-512, SHA-1, which uses which gives you an output of 160 bits, and there are a lot of algorithms even other than SHA, okay, but SHA is one of the famous one. So here I'm assuming the hash function that we are using it as SHA, okay, because in order to like make it a more simplified approach, in order to explain you in a more simplified manner, I'm just doing it, okay. So yeah, before looking at it, like just don't worry about this image. This is nothing but the structure of HMAC, and don't get don't worry at all. It's actually very simple. It is not at all complicated as it looks. It's just a block diagram. So now I will just show you the things. Like just don't worry. Like, let us see. One by one we will go from here to that. So yeah, starting from here. What is K? We all know, right? It's the secret key. Okay. So what is K plus? K plus is nothing but it's the padded version of the key. Okay. See, your key can be anything, right? It can be less than 1024 bits, and we all know about the SHA. Just recollect about SHA. For SHA, the input block, okay, for SHA, for the input block should be 1024 bits. Okay, if it is not, if it is lesser, then we need to pad the bits. If it is more, we need to break it and then make sure that every block is 1024 bits. Every block is 1024 bits. This is the thing we need to make sure, right? So cool. So this is the padded version. Okay, so if your key is something like this 10101, we will just put a 1 and then followed it by 000. So we will make sure this is 1024. So that is the point. Okay. So now, what is iPad? iPad is nothing but it's a value. Okay, it is 36 value 36 which is in the base of hexadecimal, which is base 16. Okay, it is nothing but 36 base 16. Okay, so when we open it, it will be coming in as this value. Okay, this value over here, right? It will be, if you open it, this is the value you will be getting it, right? 00111100 okay, which is of 8 bits. Okay, so 8 bits into 128 will be 1024 bits. Again, we are making it as 1024 bits. Okay, that is the biggest part. Okay, that's why we are multiplying it 128. Okay, so the general formula would be, if this is of b bits, the block should be of so we need to multiply it by b by 8. Okay, here 1024 by 8 is equal to 128. Okay, so that is what we are multiplying with in general, but don't worry, let's assume it as SHA-512 and then we will go down. Okay, so this is nothing but a secret key block. So let us erase that part so that it doesn't confuse us a lot. So let's erase it so that it doesn't confuses a lot. Yeah, so what is this? This is the secret. Before moving ahead, like what is this operation, you may ask me. This is nothing but a XOR operation that we are doing. Okay, and then what is this block? This block is the secret key. Okay, SI is the secret key. Okay, and then what is this block? Okay, Y0 to YL-1. These this is our message on the whole. We are split into the 1024 blocks. If it is not, in the last block we'll be padding and then make sure that all are B bits. Here B is 1024 because of SHA-512. Okay. So now what we will be doing is that, yeah, I'll explain you just part by part. So this is the block, this is this block. Now both the stuffs, all the blocks will be inputted to the hash function. Okay, and you may ask me, what is this input? Okay, what is this part? So this part is the initialization. Okay, we all can again recollect the concept of SHA. Okay, in the SHA there was one input that is being initialized, right? That was like A, B, C, D, E, F, G, like that. All are 8 bits. So all are like 8 registers were there. From that it used to initialize it, right? So this is nothing but an initialization vector for that hashing function. Okay, for SHA-512 it was this. Okay, for some other hash function it can be some other initialization function. That's it. Okay, so this is how it will happen. Okay, so this is the initialization part. This is all the blocks are put together as an input to the SHA function, and then it outputs n bits. Okay, here n is what? Here n is 512 exactly. Here n is 512. Okay, we can just erase as we go so that we will make the things look more simplified. So n is 512. Okay, here n is that, so that is nothing but 512 bits in case of SHA-512. In case of some other hashing function, that n will depend on that hashing function. So now, this n is over here, so this will be inputting 512. And then see, this is the what? This is nothing but, don't just confuse from this function. H of SI message means what? Means, okay, secret key concatenated with the message is being hashed. That is what we are telling. So that is of 512 bits. So that is of 512 bits. So now again we will be doing the same methodology over here. So for that, okay, as I told you, the block, okay, the block needs to be 1024. But what is the output? Okay, output of the hash function is 512 bits only. So we will be padding, okay, another 512 bits in order to make it 1024. Okay, so we will be padding it 2 B bits, that is 1024. So that would be one block, and one more block is that again this K plus and then OPAD now. So OPAD is nothing but here you can see over here, OPAD is nothing but it is 5C to the base 16. Okay, base 16, which is an hexadecimal value. And if you open it up in binary, it is 8 bits again. So 8 bits into 128 would be 1024 bits. Okay, so this is the OPAD, completely OPAD. Okay, OPAD is this 5C to the base 16, which is repeated 128 times, so that there are at the end you get 1024 bits. Okay, so now, okay, in general it is not 128 times, it is B by 8 times. Okay, because B is 1024 divided by 8, which is 128 in our case. So again, okay, fine. So yeah, so this is the point. So we have it. Cool. Okay, fine. So we will now erase this part also. So we know what is OPAD. So OPAD and iPad are just some things. It's actually a value that has been XORed with our padded key. Okay. So again, we will do it, and then that would be one block. This would be one block. Again, we hash it. This is also the initialization vector. We will hash it, and then whatever we are getting as an output. Okay. This is our HMAC. Okay. This is our HMAC, and this would be of 512 bits, which is fixed. Okay. Fixed in length. And this is in case of SHA-512. Okay. If you use some other hashing function, the output bits will vary, of course, but the fixed nature will stay forever. Okay, that is the biggest point to note down. Okay. So yeah, so this is the HMAC. Okay. Okay. So this is how it functions. It's actually very simple. So this is the structure diagram. Again, you can have a look at it. So yeah, so it is as simple as it looks. It's just hashing. The point is it's the same. The functionality is same, right? HMAC, MAC. Functionality is same. The work done by both are same. The way it does is what differs. Okay, the MAC and HMAC. Okay, at the end of the day, it is a function. HMAC or HMAC is a function that is used for authentication purpose. Okay, because you put message and then key. That is used for authentication purpose. Authentication purpose. That's it. So, thank you. Hope you all liked it and hope you all understood